How BCI technology works, the future of the human mind. Since the beginning of the digital revolution, we've built machines that could think faster, process deeper, and connect us more closely than ever before. But what if we could go beyond using technology and instead become one with it? Imagine controlling a computer with your mind, typing without touching a keyboard, or communicating with someone miles away using only your thoughts. Sounds like science fiction, right? Well, this is no longer just an idea for futuristic movies. This is the reality that brain-computer interface technology, better known as BCI, beginning to create. So, how does BCI technology actually work? And how close are we to merging our brains with machines? Let's dive in. At its core, BCI is a communication bridge between the human brain and an external device, usually a computer, robot, or prosthetic. The human brain is an incredibly complex organ made up of around 86 billion neurons. These neurons communicate through tiny electrical impulses, signals that travel across networks to perform everything from moving your hand to recalling a memory. What BCI does is listen to these signals, translate them, and then send them to a machine that can understand and respond. The process begins with sensors either placed on the scalp or implanted directly into the brain. These sensors detect the brain's electrical activity through what we call neural signals. Once the brain sends a signal, say, the thought of moving your hand, the BCI captures that pattern, decodes it using sophisticated algorithms, and sends the command to an external device. The device then performs the action, moving a robotic arm, typing on a screen, or controlling a wheelchair. In other words, it's the mind speaking directly to the machine, skipping the need for muscles, speech, or physical input. In the early days, scientists used what's known as non-invasive BCI devices that sit on top of the scalp, like e-caps used in hospitals. These are safer, but less precise because the skull blocks some of the signals. This allows for much higher accuracy and faster communication because the sensors can directly read individual neuron activity. It's risky and complex, but it's also the most advanced form we currently have. Companies like Neuralink, founded by Elon Musk, are pushing the boundaries of this technology. Their BCI implants consist of tiny threads, each smaller than a human hair, inserted into areas of the brain responsible for movement and communication. These threads record brain activity and send it to a computer via a wireless transmitter to enable paralyzed individuals to control phones, computers, and robotic limbs with their minds. And that's just the beginning. One of the most astonishing aspects of BCI technology is neuroplasticity, the brain's ability to adapt and reorganize itself. Once a person starts using a BCI, their brain can learn to communicate more effectively with the machine over time. In a way, the machine and the brain evolve together. This opens up a whole new world of possibilities, not just for medical applications, but for enhancing human capabilities in ways we've never imagined. Think about it. A soldier could operate drones using only thoughts. An artist could paint digital masterpieces without ever lifting a brush. A person who lost their ability to speak could communicate fluently through a computer-generated voice. And in the distant future, humans might even be able to share thoughts or emotions directly with each other, what some researchers call brain-to-brain communication. BCI isn't just about controlling machines. It's also about understanding ourselves. Scientists are using this technology to map how different parts of the brain function, helping them study neurological disorders like epilepsy, Parkinson's disease, and Alzheimer's. By decoding the brain's language, they can develop personalized treatments and even restore lost abilities. But let's take this one step further. What if BCIs could store or transfer human memories? Theoretically, if we can record neural signals that represent thoughts and memories, then someday we might be able to upload them to a computer or another brain. It sounds impossible now, but early experiments have already shown memory restoration in animals. This could one day lead to humans backing up their consciousness, essentially living beyond biological limits. Of course, Every groundbreaking technology comes with ethical and security concerns. With BCIs, the biggest questions revolve around privacy and control. If your brain's data can be recorded, who owns it? Can it be hacked, manipulated, or stolen? Imagine a world where companies or governments could read your emotions or intentions. That's why researchers are urging for strict laws and ethical frameworks before BCI becomes mainstream. There's also the issue of inequality. Like most cutting-edge tech, BCIs are expensive. In the beginning, only the wealthy or privileged might have access to enhancements that make them smarter, faster, or even more capable than the average human. This could widen the gap between the upgraded and the unaugmented. Some fear it might even create a new class divide between the connected and the disconnected. Despite these challenges, progress continues. Scientists are working on making BCIs smaller, safer, and more affordable. Wireless versions are being tested that don't require bulky machines or surgical implants. Some even use light-based systems, called optogenetics, to communicate with neurons more naturally. Over the next few decades, BCIs could shift from medical devices to everyday tools just like smartphones did. Imagine a future where you could type messages with your mind, translate thoughts into different languages instantly, or access the internet without ever touching a screen. You could upload skills directly to your brain, just like downloading an app. A world where human thought and artificial intelligence merge seamlessly, blurring the line between biology and technology. And perhaps the most profound question of all, if your mind can live inside a machine, what does it mean to be human? Will consciousness be something we can replicate? Or is it something unique that can never truly be digitized? BCI technology might bring us closer to finding that answer. So, as we stand on the edge of a new era, one thing is clear. The brain-computer interface isn't just another technological advancement, it's the key to unlocking the full potential of the human mind. The connection between thought and machine will redefine how we work, communicate, heal, and even exist. The future isn't just about smarter devices, it's about smarter humans. So, what do you think about this merging of mind and machine? Would you ever connect your brain to a computer if it meant becoming more powerful, or does that idea make you uneasy? Let me know your thoughts in the comments below. And if you found this video fascinating, don't forget to like, subscribe, and hit the bell icon for more deep dives into the future of technology, because the next big revolution might just start inside your head.